Assalamualaikum. So we continue back on revision June 2018 question 2 part 3. So we continue on the phase table in this part. We just finished this part for magnitude table. So for phase, it also depends on all the factor in the open loop transfer function, all these four factor. So this is the starting column for the phase table. So we start with number 6, which is STDEG is the starting point for phase in degree for each factor based on 10 frequency response theory. So for this part, you need to depends on this right part in the 10 frequency response theory this is the information of the starting and slope for phase plot. Okay, for the factor number 1, which is the constant based on theory number 1. So the starting point is 0 degree. So you write it as 0. So this is the pole at origin. Second factor is pole at origin. The starting point is negative 90 degree. So you fill up here negative 90 degree. The third and fourth factor is pole. Theory number 7. So for this one, for phase, the starting point is 0. So you put as starting point as 0 degree. So this is the total for the starting point, which is negative 90 degree. Meaning that your phase plot must start at negative 90 degree. The next column is based on number 7. FR is the frequency range. So this frequency range, okay, be careful, listen carefully. For frequency range, for each cutoff frequency in 3, column number 3, okay, minimum range is cutoff frequency divided by 10, meaning that, okay, this one we do not have cutoff frequency for constant and pole at origin, so there's no frequency range. For the next one, pole based on theory number 7, this 2, it has cutoff frequency at 3 and 60. We do it for this one first. If the cutoff frequency is 3, the minimum frequency range is cutoff frequency divided by 10, which is 0.3. Maximum range is cutoff frequency multiplied with 10. So 3 multiplied with 10, 30. So the frequency range is between 0.3 until 30. This is how you write or you determine the frequency range. Okay, we try another one. If we have cutoff frequency for the fourth factor, the cutoff frequency is 60. So the frequency range is, the minimum range is cutoff frequency divided by 10. 60 divided by 10 is 6. And the maximum range is cutoff frequency multiplied with 10. 60 multiplied with 10 is 600. Therefore, the frequency range for this cutoff frequency 60 is 6 until 600. The minimum range is actually 1 decade before the cutoff frequency. Okay, if your cutoff frequency is 3, 1 decade before is 0.3, which is divided by 10. And the maximum frequency is actually 1 decade after the cutoff frequency, meaning that if your cutoff frequency is 3, 1 decade after this cutoff frequency is 30, which is multiplied with 10. So frequency range is actually 1 decade before the cutoff frequency until 1 decade after the cutoff frequency. Okay, 1 decade before you need to divide by 10, 1 decade after you need to multiply by 10. So this is how you determine the frequency range. 1 decade before the cutoff frequency, which is this is the minimum range, divide by 10, and 1 decade after the cutoff frequency, which is you multiply by 10. Same goes to this one. There's no total for frequency range. Okay, we go to the next column. Number 8 is the starting frequency of baud plot. Okay, the starting frequency of baud plot for phase is equal to the starting frequency for magnitude plot. So number 8 is equal to number 4. Number 8 starting frequency of baud plot is equal to number 4 starting frequency of baud plot. This one, please refer to the question. Sometimes the question asks you to start your baud plot at 0.1 radian per second, and sometimes the question asks you to start the baud plot at 0.01 radian per second. So be careful, read the question carefully where you should start your dot plot, either 0.1 or 0.01. So number 8 should be same as number 4. Okay. Number 9, arrange the frequency range in a 7, this one, from low to high. So this case we have 4 values, 0.3, 30, 6, 600, arranged in order, in increasing order from low to high. So 0.3, the next one is 6, the next one is 3, and the highest one is 600. This is how you arrange this frequency from the frequency range. Okay, if you have another one frequency range, meaning that you have to add another 2 column. Okay, and the next one is number 10. Okay, you need to determine the endpoint phase negative 270 in this case. How to determine the endpoint for phase? You calculate the ending point for phase in degree. Okay, this is the theory. If you have gain in the transfer function, like this one, the constant, it will contribute 0 degree. If you have 0 at the numerator, it will contribute 90 degree, positive 90 degree. If you have pole at the denominator, one pole will contribute negative 90 degree. In this case, we have 3 poles, pole at origin, pole at negative 3, and pole at negative 60. Each pole will contribute negative 90 degree. Okay, how to calculate? Okay, this is the formula. Okay, since we have constant, so gain, we contribute 0 degree. We have 3 poles, so the first one, pole at origin, it will contribute negative 90 degree. This is pole at origin. And then we have another pole at negative 3. It will contribute another negative 90 degree. And we have the last pole at negative 60. So we have another negative 90 degree. So we sum up this 0 and minus 90 degree, minus 90 degree, minus 90 degree, and the ending point of your phase plot is at negative 270 degree. And now we go to 11, slope for magnitude in dB for each factor based on 10 frequency response theory. I continue this one starting number 11 in the next video. Thank you very much.